with logs here, and well, technically it's an exponential function. So the easiest way to try to solve these is to get the base of the exponents to be the same, but 7 is a prime number. You could make this, like you said, a base of 5, but that doesn't really help us out in this case. We could square and then take a third, take 3 out of this, and you'd be left with like a third, but I doubt the third power of 125 is really going to relate to either 49 or 7, right? So what we can do is we can take the log of both sides. So we'll take a log base 10 of both sides here. So when we do that, we'll take log, and usually don't have to write base 10 because it's assumed that it's the base 10, right? And when we do that, we get log base 10 of 125, and our exponent essentially comes down, so we get times 3x plus 1. So it's 3x plus 1 times log base 10 of 125. And then we do the same thing on the other side. The 2x will come down in front, so it's multiplied by, bracket here, the log base 10 of 7. Okay. So we can get actual values for those. So we'll plug it in a calculator, and I already quickly did that. So we have log base 10 of 125, and we get 2.09691. I guess we'll go right to the 1, 2, 3, 4, 5th decimal place. We'll try to be as accurate as possible. And we could technically keep these in a log. You know what? Let's do that before we actually turn these into decimals. What we can do here is let's put both logs on the one side, and we can divide on the other with our x value. Let's see if that will help us out. So when we go to move log of 125 to go to the other side, we would divide by it. So we'd get log of 125. And then the same concept holds here with our 2x. Because it's multiplied, we would divide this side by 2x. So essentially what happens is the 2x is gone on this side, and the log 125 is now gone on the other side. So let's see if this helps. We get 3x plus 1 divided by 2x, the bigger one on there. And then we have of log 7 over log 125. This will be just a value. We have a division here. We can split it. We still have an x on the bottom. Looks like we're probably going to have to equate this. And then what I'm going to do is I'm going to move the 2x back over. So it's kind of pointless. Well, not pointless, but it gave us a different view of the equation. So we'll actually equate that. So let's see what our calculator tells us. We have log base 10 of 7 divided by log base 0.403, let's say. So 0.403. And we'll do each one step at a time. I could eliminate here, and I had 1 over 2x, and we could get rid of the x's if we really want it, but I wonder if that would be helpful. Okay, I could split this side also. I could turn this into 3x over 2x plus 1 over 2x. And that would essentially, our x's cancel out. We have 3 over 2 plus 1 over 2x. We can move 3 over 2 to the other side. It'll give us another value. And then we could kind of switch the 2x and the 1, 0.43. Let's do that. So I'm going to split this side of the equation. Does this step make sense? It's in blue here, how I split it. So when I split it, I'll be left with 1 over 2x plus 3 over 2, okay, is equal to, and I guess we could have kept it as logs, but we've already equated it. We can move the 3 over 2 to the other side, so minus 3 over 2 or minus 1.5. Okay, and that would leave us with 1 over 2x is equal to, let's take this value. So I have the old value in here, and we'll subtract 1.5 from it. Oh, I think I gotta put the answer in from before. There you go, minus 1.5. Negative 1.069. So I'm going to keep this value in my calculator. I'll write it out to I'll round it to the third decimal place for now. So we get negative 1. I think it was 9. Oh, I have a terrible memory.
1.096.
Perfect.
Or 97.
Yeah, let's do that. We'll keep that number in there. And then what we can do is I can move the 2x over, and when it comes over, we multiply by. But I'm not actually going to multiply it. What I'm just going to do is I'm going to move this value in place of the 2x, and this will kind of come over here. Okay, and that way I don't have to get a very odd coefficient. I'll get some number 1 divided by whatever that is, right? So that kind of eliminates. So we have now 1 over negative 1.097.
Divide that by 2.
Yeah, and then, yeah, and whatever that value is, exactly, we can divide it by 2. Perfect.
Negative 0.46. Approximately.
Approximately, okay. So there's an approximation.
Is it better to use the dot or the squiggle?
They both mean the same thing.
Okay.
Yeah, so that's one way to do it. There's probably a couple others. And you can always check by plugging in our values here to see if they equate.
I didn't